Well, hello, geometry students. I'm sorry I can't be there today with you, but as you know, I'm on the Kaliva trip with the freshmen, exploring caves and sleeping under the stars and eating s'mores and hot dogs and doing all that sort of fun stuff. So what I did for you this week is I made a bunch of videos for you to watch so that we can keep moving through the material. I hope that you enjoy them. I certainly put a lot of work into them, so I hope that they're helpful. We just took our Chapter 2 quiz. We're done talking about material from Chapter 2 specifically. However, we're going to continue to use a lot of that material as we move forward. Pretty much, we're going to prove almost everything we do, which is kind of the whole point of this class. So, let's get started applying what we learned in Chapter 2 here in Chapter 3. So I want to give you an introduction to Chapter 3, which is a discussion of parallel and perpendicular lines. I'm just going to call it, lines with one exclamation point because we're excited about lines. So we've got 4 goals for this first short series of videos. The first goal is to use algebra to describe lines. We talked about lines a lot last year in algebra, and so we don't want to forget the stuff that we learned. We want to use what's useful. Most of it was useful. The second thing we want to do is discuss relationships between parallel lines. I'm going to use this symbol to mean parallel throughout the videos and for the rest of the class, really, and also perpendicular lines. I'll remind you of what parallel and perpendicular mean, especially in the context of algebra and geometry, really. Goal number 3. I want to demonstrate to you the parallel and perpendicular postulates, which you will find in the beginning of Chapter 3. I will demonstrate those to you using algebra. And then lastly, I want to talk about relationships of angles in something called a transversal. You don't know what that means yet, but I assure you, you will very soon. Alright, so let's get to it. Let's use algebra to describe lines. So there was 2 main ways we used algebra to describe lines last year. And that was with 2 particular forms of the equation of a line. The more difficult form that students have trouble remembering is point-slope form. Okay, that form of the line was y minus y1 equals m times x minus x1. For the most part, we're going to set that aside. I find that the more useful and easier way, if something in math is more useful and also easier, we're just going to use that. I find that the more useful and easier way is the slope-intercept form. There's also the standard form, which we're just going to totally ignore for now. Okay, so here's the slope-intercept form. We might call it y equals mx plus b form. In it we have our variables x and y, and we have these values m and b that represent certain aspects of the line. Okay, so m, as you probably remember, represents the slope of the line, which is the change in y over the change in x for different points x, y on the line. We might write it like this, delta y over delta x. An easy way to remember that is rise over run. So if I have 2 points on a line, the change in x here is the run, so the change in x from this point to the x value of this point, which is this distance, we call that the run. The change in y would be the rise. So I run this much, I rise that much to get from here to here. So let's think about a line that has 2 points like this. We'll find the slope of the line and then we'll write the equation. I suppose first I should talk about b, which is the y-intercept of the line. Okay, remember the y-intercept, if we have a line here, and let's suppose we have our y-axis and our x-axis. We're not going to draw a dotted axis, I just want that line to really stand out, which it is. The intercepts are the places where our line crosses an axis. Here's the x-axis and y-axis. So this point here, where our line crosses the y-axis, that's the y-intercept. This point here, where our line crosses the x-axis, that's the x-intercept. Okay. Remember, the x value of a point is the location with respect to the x-axis. The special thing about the y-intercept is this is where the x value of the point is 0. I'll just put a question mark for the y value of the point. The x-intercept, on the other hand, is the place where the height of the point, or the y value, is 0. Okay? So, let's look at a line that has 2 points and find the equation of the line. Now, at the beginning of the year, we talked about a postulate, which said, it was one of our very first postulates after we even just began to think about what a postulate was. And it was that any 2 points have exactly one line between them. Okay, in this case, that means for any 2 points, there's exactly one slope-intercept form. Okay, there's exactly one slope-intercept form. Our goal for these 2 points is to find that slope-intercept form for the equation of the line. So the first thing we're going to do to find the slope-intercept form, I'm going to write it out without any values in it to remind myself, oh yeah, this is what I'm looking for. Looks like I need to find a value for m and a value for b, and then once I've done that, I've found the slope-intercept form. So here's my 2 points. For my slope, m, I want to look at the rise over the run. The rise is the distance from this y value, the y value of this point, which is 4, to the y value of this point, which is 2. I can always find that by subtracting one y value from the other. So I'm going to do y2, which being 4, and y1 being 2 to find that value. And then for my run, in order to find the run, what I need to do is do the same thing, find the difference in the x values, because that's the distance from the x value of this point, same as the x value of this point, to there. So there's the difference in the x's, there's the difference in the y's. So again, I hope you remember the formula to calculate slope given 2 points is y2 minus y1 over x2 minus x1. So let's plug those values in, 4 minus 2 over 3 minus 1. In the numerator, 4 minus 2 is 2. The denominator, 3 minus 1, also 2. So we have 2 over 2, which is 1. So there's our slope. The method that I would like us to use to find the y-intercept, there's a couple of different ways we could do it. We are going to use the relationship between the equation of the line and the points on the line. So remember, this is the equation of this line passing through these 2 points because it describes the relationship between all of the x values and all of the y values. It describes the relationship between all the x values and all the y values. Okay, so if I plug an x and y value into the equation, my x value for x and my y value for y, then whatever I get out must be true. It has to be true because it describes the relationship between x and y. If it's not true, then it's not the equation of this line, or the points not on the line. So I've got my equation y equals mx plus b. I know that my value for m is 1, and so I'm going to use a value of x and y for one of these points. It doesn't matter which point I choose. As long as I plug them in correctly, I'll always get the same answer. I'm going to use this point because I like the values 1 and 2. So I'm going to use 1 for my x value because that's the x value of the point, and I'm going to use 2 for my y value. So what I'm doing here to find the value of b is I'm plugging in everything and leaving only a b. So let's take a look at what happens. I'm going to put a y in. That's 2. My value of m is 1. My value of x is 1. So notice this is y equals mx plus b. I don't know what b is. But now I can find out what b is because I have an equation with a b in it. So I'm going to simplify. I get 2 equals 1 times 1. That's 1 plus b. So using the subtraction property of equality, I can subtract my 1 from both sides, and I get 1 equals b, or b equals 1, using the the symmetric property of equality. So now I know that b equals 1. I already found my m up here, so now I have my m and my b, which means I have my whole equation, y equals 1x, or just x, plus 1. So that's how we find the equation of a line that passes through 2 points. There's only one, and this is the equation in y equals mx plus b form. I'm going to stop this video here and pick up right here at the next video where we're going to continue to discuss algebra in the context of, well, we'll continue to discuss lines in the context of algebra.